Welcome to this episode of Career Shorts hosted by the Antibody Society, where we talk to a whole host of individuals from various sectors, including industry and academia, to gain their valuable insight into how students and postdocs can navigate the tricky world after their studies and contracts end. Now, in this episode, we're talking to Professor Charlotte Deane from the University of Oxford, who leads the Oxford Protein Informatics Group, to name but one of her many roles. Now, these episodes and more are all available directly on the Antibody Society's website. And if you're watching on YouTube, then drop us a comment in the chat below or just pop us an email. We really value your comments and any suggestions you might have. Now, we hope you enjoy this and find this a valuable exchange, so let's get into it. So, hi Charlotte, welcome to Career Shorts. I was wondering if you could just start off by introducing yourself and maybe also telling us a little bit about your role as Professor of Structural Bioinformatics and how your work involves the world of antibodies. For example, I saw that your group's doing some, seems like really exciting work with in silico design and optimization, if that's not too off the ball.
Okay, so hello, I'm Charlotte. I am Professor in the Department of Statistics at Oxford University, and I head up the Oxford Protein Informatics Group. And just so that I reveal everything, I am also Deputy Executive Chair of the EPSRC, so I also work inside funding councils as well. In terms of our research, in the Oxford Protein Informatics Group, we do a lot of work around antibodies and immunoinformatics, but our work is all primarily computational. What we're trying to do is design therapies. But that runs right through from just trying to understand fundamentally how antibodies might work, and that's antibodies, nanobodies, TCRs, but also through to how you would design them to bind better, have fewer issues, but trying to do everything on the computer if we can. And I should say right now, you can't yet do everything on the computer. So it's all about where we fit into the pipeline of other steps and how we can shorten times and how we can make it easier to do the experiments that need to be done.
The news with AlphaGo, did that have any impact or confidence about where everything will be going in terms of future research with antibody and in silico design for you guys?
I think on the one hand, it's sort of a yes and no to that one, because the AlphaFold 2 software, and actually I've spoken to some of the people who've been involved in developing that, they talked about, how they can predict the folds of proteins, but something like antibodies is something that's very difficult for them, because the way their software works, it's about effectively producing an approximation based on kind of lots of sequences sharing the same shape. And what's exciting about antibodies is lots of very similar sequences having very different or slightly different shapes that have different functions. So it's unlikely that that exact breakthrough will have an impact on, if you like, structural understanding of antibodies, but it will have a breakthrough on having structural information on the other side, so on your targets. So that will change everything about how we might want to be looking for our targets and how we might use our computational tools. But it also points at the ability, and there's been papers from lots of other groups, and it's a very fast moving field, suggesting we'll be able to do much better at structurally predicting antibodies themselves as well. So I think that for me, it's really exciting, because our whole premise when we started doing this work with antibodies is that people should be thinking a lot more structurally than they were. That you should start by saying, see, we know how things bind or how they work by understanding their three-dimensional shape. And these kinds of papers that are coming out now suggest that we're going to know their three-dimensional shape. So it even pushes even harder and even faster. We should be basing this on the three-dimensional shape, because that tells us about the function of these. It's not just, I know its shape, that's nice. It tells you how it will function. And so we should be using that information right from the start.
And that kind of answers my next question, where I wanted to ask you, what excites you and keeps you in the world of antibodies? And that seems to be something that excites you a lot.
Yeah, I mean, I guess it's related to that. What really excites me about it is partly because it is such a fast moving field as well. It's really highly relevant. And because it moves so fast, you've got to think all the time about what you would change, how you would develop, what you would do next. And I guess, if I'm honest, for me, a big thing about that is learning new things constantly. It's the big reason I got into academia. It's the big reason I enjoy my job so much. I like learning new things. And this is a field where things move fast. So I get to learn lots of new things all the time.
And I'm following up on that. What's been the most rewarding part of your career so far?
Yeah, I think there's only really one answer to that, which is working with my group, my students and my postdocs. It's amazing to be part of that dynamic. It's always really exciting because you have this constantly, if you work in an academic group, you've got new people coming in all the time, and they bring with them really different ideas, different ways of seeing, the same problems that I've seen for ages. And I have to be honest, they always surprise me. I never think they will. I always think, well, I understand what's going on. But they always surprise me, they always push me, and I learn a huge amounts from them. I hope that through the process of working with me, they also learn too. But I think it's that kind of thing, being able to have that kind of research environment and work on something like that I really enjoy. It's my favourite thing.
And I guess, for many students that are at the end of their PhD or finishing up a contract as a postdoc, for many of us, it can be a difficult decision, whether to stay in academia or to leave and go into industry, for example. You've touched on it briefly, but what was it specifically about academia that drove you to stay? And was it something that from the onset of starting your PhD, for example, that you always wanted to stay in academia, or was it something that kind of changed along the way?
I think probably throughout my PhD, I would have said that I wanted to stay in academia because I had kind of big research problems in my head that I was hoping I would get the kind of freedom to explore. And I'm very, very lucky that that's how that's happened for me. But I should say the other part of this is it's interesting. The further I've got on in my career, the more I've been doing, the more I have worked more and more closely with industry, and a large number of the students and postdocs through my group go straight into industry now. And I understand much more the decision why. And I think perhaps I actually wasn't very well informed when I was making my choices about what was possible in other realms. So I think it's actually a better place now. Students and postdocs are being exposed to a lot more of, what they might be able to do in industry and how their skills might fit in there, and be able to make a more informed choice about what they want to do, which I think is important. And I don't think I actually did particularly. I think I ended up by chance in the right place, but I think it's better to know more and be able to make your choice more in a more informed way.
Yeah, and speaking of that transition, of kind of keeping in academia, because we all know how intensely competitive it can be to attain a position at university, and hence why many students go into industry, because it's their only choice. How was your experience kind of keeping in industry and getting to be a professor? What was the most difficult part of that?
I had quite an unusual step through. So to cut a very long story short, I was sitting in a postdoc in California, and I had sent some emails because I was hoping to come on a visit home to the UK to sort of visit a few places, but it was also really because I was coming home to see my parents, and I was emailing universities to say, can I come and say hello? And I got an email from one, it was actually from Oxford, saying, there's a position, apply. And I had 24 hours to apply. I applied, and that's where I ended up.
Oh, wow.
There's lots more to that story that involves things like FedExing my laptop across Americas, because I was actually on holiday at the point in time when I got asked to interview, and all these kinds of things. It was a very odd experience. But for me, actually, it wasn't a kind of, horrific experience of applying for thousands of things. But I'm very well aware that that is the kind of system we're within. And so the things I want to say are things like, don't give up on it. Think about what you want to do and work out the way to get there, and think about the skills you need to do that. So sometimes it's not about getting your dream job first time out, because certainly the first job I got at Oxford, I wouldn't have written down, if I was writing down the ideal job, it wouldn't have been that one. But it gave me all the skills for the next steps that I wanted. And I think that's a really important thing, to think about it in terms of what will actually give me the things I need for the next career step. And the other thing is, I don't think choosing to go into industry now means that you would never be in academia ever again. There's much more porosity, I don't really like that word, but much more movement backwards and forwards between the two, which is fantastic for both. And so I don't think you think, well, if I don't get this academic job, then it's all over and I'll never work in a university. actually loads of the skills that you would have going through working in industry, and the same on the academic side, are useful on the other side, and moving backwards and forwards can be really powerful now. So I think less fear on all of that and more just explore what you want to learn and go and find the places that let you do that.
And I think it's interesting what you said, where you directly contacted just to go and visit universities and just going to speak in the department rather than specifically applying for particular positions. And I thought that's quite interesting. And the fact that, you know, sometimes, as you said, what seems like not the ideal job can sometimes lead you down a path that can actually open many doors, or sometimes end up being the ideal job that you were looking for, but you just didn't realize.
Yeah, I think it is always worth, if you're at a stage where you've got things that you're ready to present or ready to talk about, there is never any harm in contacting groups and saying, you know, I'd love to come and tell you about this. Because if they're interested, getting you to come and give a talk is not much effort for them, an amazing experience for you, and it, if you like, gives more kind of visibility on both sides about what's possible at that university if you'd like to work there, what might be there, and for them to know you exist and, you know, all sorts of other things about you. And I always think, you know, it's very difficult to know what a job is like before you do it. So, you know, when I first came to Oxford, the job I got certainly wasn't the ideal one for me. But if you ask me now, it pretty much led to all of the ideal jobs that I have now. So I'm never going to say I got that wrong. I just didn't know. And so I think a lot of it is being brave enough to step through the hoops and going, well, this is good and this is exciting, so I'm going to give it a try and see what happens. You can always get a different job if it doesn't work out.
What are some of the considerations that you would have for any students that do decide to continue on and try and do a postdoc? Are there any qualities that, for example, especially in their applications, that they should be highlighting that you notice many fail to do?
So I think if I'm thinking about when we're getting to kind of the postdoctoral level, there are lots of things that are kind of trying to get people to show, and some of them you can't show on an application, some of them you have to show in an interview. But I think it's really important to show off your communication skills. So communication is not just about talking, but make sure you write well, because that's a really important part of what's going to happen. And something else that I think it's hard to show on a piece of paper, but it's really important to get across in an interview, is your ability to see the big picture. So it's very likely that you've done some excellent research on a particular topic during your PhD, and there'll be lots of other people who've done that. But what really sets people apart who are going to, and I don't think this is just for academia, I think this goes broader than that, is the people who know why that piece of research was important, how it sits in a much bigger picture, and all the other pieces that are needed, even though they didn't do any of them. And I think that's quite hard to show, but I think it's very, very, very important. And then the last bit, and I think this is a purely coming from the work that I do, is having this kind of acceptance and willingness to learn, but also to be wrong. I think a lot of people get very defensive if you suggest, you know, what did you get wrong? How did this not work? But by definition, if what we are doing is brand new, a lot of what we do will fail and be wrong. And that's actually fine. And the most important thing is to be able to recognize that, not to run away from it, because sometimes it's really interesting to know that something doesn't work, or, you know, I made a mistake. And so I think those are skills that it's hard to get on the piece of paper. On the piece of paper, it really is show your core knowledge, your understanding, you know, and you can show off some of your communication and big picture by the other things you've been involved in, the talks you've given, the posters you've presented, the work you've done that's broader than just your own topic. So basically demonstrate that you're ready to think about research in that way.
I think what's exciting nowadays is with social media and blogs and things, I think a good way to practice your science communication in the bigger picture is creating a blog or doing a YouTube video or something like that. I think that probably will help a lot as well.
Yeah, I mean, I think that's it. Show it off somewhere. And don't worry about showing it off, because if I'm trying to hire you, I want to see that. I want to know you want to do these things and you're good at it.
And quick fire question, are grants as much of a headache as they seem?
I'd say yes. I think the problem is, and the sort of short part of that is, it's you put an enormous amount of effort into something which is very likely you're not going to get the money for it, regardless of how good it is, just because there's not enough money around. So yes, they very much are. But on the other side, when you do get them, the freedom they give you and what you can do with them is generally, you then decide it was all worth it for the times when it didn't work.
And looking back on your days as a graduate student, is there anything that you would have changed or kind of told your younger self, like to reassured yourself that, hey, everything's going to be okay, or don't worry about this or that?
So I think there are lots of times when I would have wanted to reassure myself. So when I was doing my PhD, the first Christmas, so I've been doing it for, I don't know, 3 months then, I can remember telling my dad that I wanted to quit. Because I couldn't work out what I was going to achieve. I couldn't work out how it all fitted together. I didn't feel like I was getting anywhere. And I mean, obviously I didn't. And I think that feeling of being a little bit out of your depth and everything being a little bit confusing is almost a good feeling, as in it's horrible, but actually if you think you've got everything under control, you probably haven't at all, and you're probably slightly better if you're feeling on that edge of not really, having it all.
Yeah.
So that's one thing. And then another thing would be almost the opposite of the thing you said about, academia is very competitive, worry about getting a job, and I had all of that, and I think lots of students do. And I want to say to them, don't worry about that. Focus on your aims, what you want to achieve, and look for the opportunities that are right for you, because there are opportunities. And yes, it's competitive, but so is everything else. Because it's not like getting a job in industry is not competitive, or getting a job to do it's all competitive. So just focus on what you want to do and what you find exciting and interesting, and work out the best way of getting there. And what I mostly see then is that people do, if that's how they treat it, as something that they just really want, and they want to do it, and they think about the best way to do those things.
And what would you say are some of the most important qualities for a scientist to succeed, and skills that are kind of valuable away from the lab? But we know we've touched on this, like science communication and that sort of thing, because as you mentioned before at the start, and you can see online, I know that you're the deputy chair of the ESPRC. So for our non-UK audience, that's the Engineering and Physical Sciences Research Council. I can imagine that this role and the roles before really allowed you to nurture and cultivate your communication and your management skills.
So I think communication is a big one. I think learning how to manage projects is one of those things that you have to develop through time. So I always think of it a bit like this. When you're a PhD student, you basically manage your own project, which is still quite a big deal, actually. It's very different from most people's first job, being given complete responsibility to manage something and make it happen. And then put around that, you start collaborating with some others, you develop that. And if you're really lucky, you get a tiny bit of experience of looking after, say, an undergraduate student or a master's project. And then you move on to being a postdoc, and that expands slightly. You might be managing your own project, but your own project might be 3 or 4 strands now of more things. You'll almost certainly be managing some people to do some other things. And through all of this, you're also managing upwards. Because you have a supervisor of some description who you're trying to persuade that what you're doing is a good idea and not to irritate you at the wrong moments in time while you try and do it. And this just keeps going. So when you start having your own research group, now you're managing lots of people doing projects. And then there becomes this difficult phase, because, and I have to say, it's one of the hardest things to do when you start that role of being in charge, being a PI, is handing over your very best idea to some 22-year-old to screw up. And that sounds like I'm being rude. I'm not. It's just that you understand it perfectly. They obviously don't. And that's a whole new area of learning how to, it's not just manage that person, because if you just sit on them, you might as well have done it yourself. It's actually the learning how to not do anything, how to step back, how to trust, how to let them develop those skills on their own. And so I think that kind of development is hard, and it's really important to take opportunities to learn how to do that. It's really important if you found people you trust and admire or you think are good at these kinds of things, ask them to be your mentor, even if it's just to talk to you occasionally, so that when you have difficult questions as you step through, just even from PhD to postdoc or postdoc to PI, you have someone to ask about, is this normal? Does this happen? What do I do with? Yeah. And then I'm quite passionate about this. I think that people should then step up and get themselves involved in other parts of, the scientific world. So I could just run my research group in Oxford, but that's one of the things I do. I also think it's important, if I'm lucky enough to get to a stage where I can do this, but you can do it at every point. When you're a student, when you're a postdoc, involve yourself in the wider scientific community, because one, you'll help you learn all those skills. You'll see how to manage meetings. You'll watch people do it very badly. You'll watch other people do it very well. It's like watching people give talks. But it will also connect you to networks of people doing this. But also, if you want this to be a vibrant and lively community, you want to be involved in things. Be involved in the Antibody Society. But it doesn't really matter what pieces, but you want this community to exist. So be part of it. It will not only improve your skills, but it also will actually improve the whole working environment for everybody involved in the discipline and doing this kind of research.
Awesome. Thank you so much, Charlotte. Thank you very much for taking the time to speak to us today.
You're very welcome.
And that's all for this interview. Thank you very much for listening, and more importantly, we hope you found today's session insightful and valuable. If you'd like to access more interviews like this and other great content, then please check out the Antibody Society's website. Membership is free for all students and postdocs, and we have some really great value for money memberships for our academic and industry partners. Feel free to share this video and come check us out on our social media pages like LinkedIn and Twitter. If you'd like to connect with today's speaker or reach out to us, then check out some of the details in the description box below, and thank you again for listening.